Have you ever stopped to think about time? It is perhaps the most familiar yet most mysterious force in our lives. Every day we watch it unfold. We see a glass fall from a table. It shatters into 100 tiny pieces on the floor. We never see those pieces leap back up to reform the glass. We watch an egg crack into a hot pan. It sizzles and cooks into a delicious breakfast. We never witness that cooked egg unscramble itself, retreating back into its perfect, unbroken shell. This forward march of events is a fundamental rule of our existence, a constant we rely on without a second thought. It is the silent rhythm of the universe, ticking away one moment at a time, always pushing forward, never back. The idea of an arrow of time was popularized by the British astronomer Sir Arthur Eddington in the 1920s. He was trying to make sense of a new, revolutionary idea in physics. This was the concept of entropy. Eddington realized that the constant, irreversible increase of disorder in the universe could provide the directionality that time seems to have. He imagined time as an arrow, shot from the bow of the Big Bang, flying towards an unknown future. This powerful metaphor helps us grasp the scale of the problem. It is not just about our daily lives. It is about the entire history and ultimate fate of the cosmos. Everywhere we look in the universe, we see the arrow of time at work. We see galaxies colliding, their beautiful spiral arms twisting and merging into a chaotic, larger galaxy. Put simply, entropy is a measure of disorder or randomness. The second law of thermodynamics states that the total entropy of an isolated system can never decrease over time. This is not just a suggestion. It is a statistical certainty. A tidy bedroom left to its own devices will naturally become messy. A hot cup of tea will always cool down, spreading its heat into the surrounding air. The energy becomes more dispersed, more disorderly. Think of a deck of cards. There is only one way for them to be in perfect order, from ace to king for each suit. But there are countless, astronomically high numbers of ways for them to be shuffled into a random, disordered mess. If you shuffle the deck, it is overwhelmingly probable that you will end up with a disordered state. Ultimately, the second law of thermodynamics can be seen as the engine that drives the entire universe. An engine works by taking energy from a hot source, using some of it to do useful work, and dumping the rest as waste heat into a cold sink. The universe works in a similar way. The hot source was the Big Bang itself, a state of incredibly high temperature and low entropy. The useful work is the creation of every structure we see, galaxies, stars, planets, and life. The cold sink is the ever-expanding, ever-cooling space of the future. Every star that shines is part of this cosmic engine. It's a local hotspot, doing the work of forging heavier elements and radiating light. The fundamental laws of physics that govern a single particle are largely reversible. The equations work just as perfectly forwards as they do backwards. If you saw a film of two billiard balls hitting each other, it would look perfectly normal played forwards or backwards. Imagine you're looking at the universe through a special kind of mirror. This mirror doesn't just reverse left and right, it reverses time. This creates a stunning paradox. If the basic building blocks of reality don't care about the direction of time, why does the world built from them care so much? The arrow of time emerges from the collective behavior of trillions upon trillions of particles. It is a property of the whole, not the parts. It's kind of like watching a single person walk. They can easily walk forwards or backwards, but trying to get an entire chaotic crowd to walk backwards in perfect unison is practically impossible. Human consciousness is a kind of time machine, not a machine for traveling through time, but a machine for experiencing it. Our brain is a remarkable machine for recording the past. It does not, however, have any mechanism for recording the future. We can form memories of the past precisely because the past was a state of lower entropy. This makes our consciousness a kind of compass. It's a device that's intrinsically aligned with the arrow of time. When you anticipate tomorrow's meeting, you're not accessing a record. You're creating a simulation, a projection of possibilities based on past experiences. The future is a realm of imagination, while the past is a library of records. Let's think about the universe as a giant cosmic lottery. Each possible arrangement of all the particles and energy in the cosmos is like a single lottery ticket. The universe began by holding one of the rarest tickets imaginable, a ticket for an incredibly low entropy state. Since then, with every passing moment, the universe has been swapping its ticket for a more common one. This cosmic echo tells a remarkable story about time. When we map the CMB, we find that it is astonishingly uniform. The journey from that smooth, simple past to the lumpy, complex present is the grandest demonstration of the arrow of time. Why did our universe begin this way? We do not have a definitive answer. This is now one of the greatest unsolved mysteries in cosmology. So the next time you watch cream mix into your coffee, remember what you are witnessing. You are seeing more than just a simple, everyday event. You are seeing a glimpse of the universe's deepest secret. You are watching the relentless, statistical march of probability, an echo of the universe's fiery, ordered birth. You are observing the very engine of creation and decay that makes our existence possible. The arrow of time is not a limitation. It is a gift. It is what gives the universe its history, its future, and its meaning. And the quest to understand it is one of the greatest adventures we can undertake. We are the universe's way of looking back at its own history and contemplating its own future. The mystery of time is not just a question for physicists. It is a question about the very nature of who we are